Hey, what's going on, guys? It's Mr. Sanchez coming with you guys with another lesson for pre-calculus. This time we're continuing section 1.2 functions. I broke it up into two parts so that they're the topics are more easily digestible. All right, so let's go over our learning targets for today. Our first learning target is to find the domain of a function defined by an equation, okay? And there's actually a step-by-step process that we can do to go ahead and find the function, the domain. All right. On top of that, we need to know how to form the sum and difference, product and quotient of two functions. We'll go into it. It's just what happens when these are operations. It's basically operations of functions. We're given two functions. We're going to look for the sum, the difference, the product, and the quotient of two functions. Next up, let's just go ahead and get started. So this is a step-by-step process here of finding the domain of a function. It's a tried and true method, right? Finding the domain of a function defined by an equation. Okay, so first things first, you're gonna start with the domain as the set of all real numbers, okay? If you ever see the symbol in math, that means the set of all real numbers, okay? So if you ever want to avoid writing all real numbers, then you usually just write this. R is the set of all real numbers. And I'll write that down. Okay. After that, if the equation has a denominator, exclude any numbers that give a zero denominator. So that comes from our second step. If the equation has a denominator, exclude any numbers that give a zero denominator. And the last step would be to, if the equation has a radical of even index, exclude any numbers that cause the expression inside the radical to be negative. And if you don't know what this means, don't worry. We're going to go over three different examples that pretty much tell us what we have to do. Okay, so problem one. All right, we have f of x equals x squared plus 5x. We're just going to follow this process. All right. So first, let's just start with the domain as a set of all real numbers. Okay, so we're going to say that the domain is all real numbers. And then step two says if you have a denominator. Do we have a denominator in this equation? No. So we can ignore step two. Do we have a radical? No. We can ignore step three. So just by looking at this function, we can say that the domain of this function is going to be the set of all real numbers. You can always just write x such that x is in R. If you ever see me write this is called set notation, and this is saying x is some number. If our domain is x, this line here means such that, right? Our variable x is, and if you see this epsilon right here, is inside R, which is all real numbers, as you said. So I write it like this, and you're allowed to write it like this too. The only difference is you need to know what it means. All right. So this is basically us saying the domain is all real numbers. If that's a little bit too complicated, you can write all real numbers, and that's fine. Okay. This is just the set notation of doing that. That's x such that x is in R. Okay. We're gonna go over to example number 2. All right. Number 2, we have this function g of x equals 3x x squared minus 4. Now, if you look at step 1 again, our first step starts with the domain as all real numbers. Okay. X is all real numbers. So for now, we're saying all real numbers. Okay. For now. And then it says if the equation has a denominator, exclude any numbers that give a zero denominator. Okay. So to do that, we're gonna erase this. To find out what our domain is, we gotta let the denominator equal to 0. We don't care about the top. So we're gonna start with x squared minus 4 equal to 0, and then we're gonna get x by itself. You can do the square root method where we do plus 4 to both sides. All right. This goes away. You're gonna get x squared equals to 4, and then you take the square root of both sides. And you're gonna get x is equal to plus or minus 2, right? So since those are the numbers that make this equation 0, we're going to say that the domain of f of this function g of x cannot equal 2 and x cannot equal -2. Okay. Why is that? Because if you put +2 inside here, if you put that in here, you're gonna get 2 squared minus 4, which is 0. So that's why our domain cannot equal x. And normally you'd write x such that x cannot equal 2, x cannot equal -2. All right, for the last one, you're gonna see that it's a radical problem. All right, so problem step 1, assume it's all real numbers. Okay, step 2, check if there's a fraction. There is no fractions here, no denominators, so we can ignore step 2. Step 3 says determine what makes this negative, right? So we cannot have the inside be negative, right? Is any numbers that it cause the expression inside the radical to be negative, right? So what we're going to do is we're gonna take the inside and we're gonna try and solve for this. So we're gonna do 4 minus 3t. It has to be greater than or equal to 0. Why does it have to be greater than or equal to 0? Because those are all the numbers that are gonna give you a positive or a 0 number. We cannot, under any circumstance, have the expression inside the radical become negative. So we're gonna do some algebra to get t by itself, right? Plus 3t. You're gonna get 4 has to be greater than or equal to 3t. Divide both sides by 3. That goes away. You're gonna get t has to be less than or equal to 4 over 3. Okay, that's our domain. Domain has to be t has to be less than or equal to 4 over 3. Otherwise, we're just going to get negative numbers, and then that's not going to be part of our domain. Okay, and that's basically it for domain and range. If you get you just got to follow these 3 steps. First, assume that it's all real numbers. If you happen to have a denominator, then you got to get rid of anything that does not have a denominator, just like here. That will make the denominator 0. And then if it also has a square root or a radical, well, it has to be even power. So this is the square root. It has to be 4, like it has to be 4th root, 6th root. Otherwise, if it has a cubic root, 5th root, an odd number, then it can be all real numbers. Okay. But yeah, that's basically the gist of finding the domain. We'll have a lot of practice in class, so don't worry if this does not seem very clear at first. Okay. And then step number 3, and then we're gonna go on to our next slide, our next set of problems, right? So that's the first half. Right now, the second half is finding the sum difference product of a quotient. All right. So we're gonna be, for our following problems, we're gonna be using these 2 functions. Okay, f of x and g of x. F of x equals 3x plus 4. G of x equals 2x minus 3. The sum of 2 functions is defined as the following. If you have f plus g of x, that's going to be the same thing as f of x plus g of x. So to find the sum, you're literally going to write the same thing. So what's f of x here? You're just going to follow this formula right here. What's our f of x? F of x is 3x plus 4. So you're going to put that in parentheses, 3x plus 4. Right, this is our f of x. Plus our g of x. What's our g of x? 2x minus 3. So you're going to have 2x minus 3. Okay. I put the parentheses at first, but then you can remove them because it's not really going to affect our problem. And now what we got to do is combine like terms. What's 3x plus 2x? That's going to give us 5x, right? And then 4 minus 3 is going to give us positive 1. So we get that f plus g of x is actually equal to this. Okay, that's our sum of the two functions. Very similarly, you're going to do the same thing with the difference function, right? For our difference, you're going to have, when you have f minus g of x, that's the same thing as f of x minus g of x. So we're going to have f minus g of x equal to 3x plus 4. And this time putting the parentheses really matters. Minus our g of x, 2x minus 3. Don't forget to distribute our negative here. So this becomes minus and this becomes plus. And you got to evaluate now. 3x plus 2 minus 2x, that's going to be x. And then 4 plus 3 is going to be 7. So our f minus g of x is going to be equal to x plus 7. All right. Now let's go to the product function, right? The product of two functions is going to be what you get when you multiply f times g of x, right? So you're going to get, to get the product, you're going to do f times g of x is equal to f of x times g of x. You're going to get 3x plus 4 times 2x minus 3. And then to solve this one, you have to FOIL, right? So you're going to get 3 times 2, which is 6x squared, minus 9x, plus 8x, minus 12. And then when you evaluate this, you're going to get 6x squared, minus x, minus 12. And that's what you're going to get, that f times g of x is equal to. Okay. Pretty straightforward. And as for the last one, to get the quotient, you're going to divide the two functions. So our f of g of x is going to be equal to our f of x, which is 3x plus 4, over our 2x minus 3. And that's it. You do this one like that. We can't simplify it anymore. If you get a square, if it's something factorable, then you're going to have to cancel out the factors. But for the most part, this is going to be our f over g of x, the quotient of the two functions. And that's basically it. And now you should be able to have an idea of what you're supposed to do for the problems in your homework. I hope this video wasn't too long, guys. I'll post all the homework to get tonight. And if you have any questions, feel free to message me on Schoology, on YouTube, or talk to me in class. All right. Everybody have a great day. Bye-bye.